What's up guys, welcome back to another video, and for this video I will be doing the summary of chapter 1 to chapter 11, all the chapters in the Cisco.NET Acad. So I hope you learned something. I hope you got some informations about the chapters 1 to 11, and I hope you stay tuned and stay watch until my video is finished. So for this first, I will be doing the summary of chapter 1. So, chapter 1, lunch course. Okay, so for the introduction of the chapter 1, we now saw that a critical turning point in the use of technology to extend and empower our ability to communicate. So the globalization of the internet has succeeded faster than anyone could have imagined. The manner in which social, commercial, political, and personal interactions occur is rapidly changing to keep up with the evolution of this global network. So in the next stage of our development, innovators will use the internet as a starting point for their efforts, creating new products and services and specifically designed to take advantage of the network capabilities. So as developers push the limits of what is possible, the capabilities of the interconnected networks form the internet will play an increasing role in the success of this project. So this chapter 1, exploring the network, introduces the platform of data networks upon which our social and business relationships increasingly depend. So the material lays the groundwork for exploring the services, technologies, and issues encountered by network professionals as they designed, build, and maintain the modern network. So for this chapter 1, there are 5 topics. So the first one is the globally connected. Then the second one, or the section 1.2, is the WANs and the internet. And the network, the next one is the network is a platform. Then the second to the last is the changing network environment. And the last one is the summary. So, networking today. So, networks in our daily lives, among all of the essentials for human existence, the need to interact with others ranks just below our need to sustain life. So, communication is almost as important to us as our reliance on air, water, food, and shelter. So, in today's world, through the use of networks, we are connected like never before. So, people with ideas can communicate instantly with others to make those ideas a reality. So news, events, and discoveries are known worldwide in seconds. So individuals can even connect and play games with friends separated by oceans and continents. So when there are some videos, news all over the world, it can be possibly viewed or watched by the other people in the other continent, and that's why our life is go easier because of the networks and the media that we are using in our daily lives. And there are no boundaries between the network, between the other people and us. And then they're providing sources in a network is networks comes in all sizes. They can range from simple networks consisting of 2 computers to networks connecting millions of devices. So, the first one is the small home networks. The small home networks is connect a few computers to each other and the internet. So, the small home networks, for the small home networks, it can be possibly between with the two or more or 2 or less computers to be connected, and it is small network because it is only in the home. But the next one is the small office or home office. So Computers within a home, computers within office or a remote office to connect to a corporate network or access centralized shared resources. So when we are in the inside of the office, we can see multiple laptops or computers that are connected in one network. So the network is connecting that computers to use. Then the next one is the medium to large networks. Medium to large networks such as those used by corporations and schools can have many locations with hundreds of or thousands of interconnected computers. So when the medium to large networks, it is the one network that can connect many computers and laptops to the networks. And the worldwide networks, the internet is a network that connects hundreds of millions of computers worldwide. So when the worldwide networks, it is connected 100 of million computers worldwide. And the LANs wants an internet. So the LAN is it is a type of network, and the meaning of the LAN is the local area network. So the network infrastructures can vary greatly in terms of size of the area covered, then number of users connected, the number and types of services available, and area of responsibility. As I told earlier, the local area network or the LAN is a network infrastructure that provides access to users and devices in a small geographical area, which is typically an enterprise, home, or small business network owned and managed by an individual or IT department. So the LAN or the local area network uses when the networks didn't need a big amount of computers or media that can be connected to the network. But the WAN or the wide area network, it is a network infrastructure that provides access to other networks over a wide geographical area. So it is typically owned and managed by a telecommunication service provider. So when it is the one that has a bigger area to be connected. And the other types of network include is the MAN or the Metropolitan Area Network, then the wireless LAN or the WLAN, and the SAN or the storage area network. Then for the summary of chapter 1, it is this chapter focused on networking as a primary platform for supporting communication, and the next chapter or the chapter 2 will introduce you to the Cisco Internet Networks Operating System or the IOS. So for the chapter 2, it is the Configure a Network Operating System. It is the iOS Bootcamp, the basic device configuration, the other schemes. So the iOS Bootcamp or the Cisco iOS, it is the operating system, and all end devices and network devices require an operating system or the OS. So the portion of the OS that interacts directly with computer hardware is known as the kernel. So what is the kernel? So the kernel communicates between the hardware and software of a computer and manage how hardware resources are used to meet software requirements. Then the shell, it is the user interface that allows user to request specific task from the computer, and this request can be made either through the CLI or the GUI interface. And the last one is the hardware. It is the physical part of a computer including underlying electronics. And the address schemes or the ports and addresses, the configure IP addressing, and the verifying connectivity. So for the summary of chapter 2, so for this chapter, the chapter 2 introduces the Cisco IOS. So it detailed the various modes of the Cisco IOS and examine the basic command structure that is used to configure it. So for the next chapter, the chapter 3, it explores how packets are moved across the network infrastructure and introduced to the rules of packet communication. So for the chapter 3, they are the rules of communication, the network protocols and standards, the data transfer in the network. So the rules of communication, so the rules is a network can be as complex as devices connected across the internet or as simple as two computers directly connected to one another with a single cable. And anything in between, networks can vary in size, shape, and function. And however, simply having a wired or wireless a physical connection between end devices is not enough to enable communication. So for communication to occur, devices must know how to communicate. And for the network protocols, the protocols are the protocol suits, the standard organization, and the reference models. And for the section 3.3, the data transfer in the network, the data encapsulation, and data access. And applying models allows individuals, companies, and trade associations to analyze current networks and plan the network of the future. So for the next chapter, for the chapter 4, it is the network access, it is the physical layer protocols, the network media, and the data link layer protocols and media access control. So for the chapter 4, to support our communication, the OSI model divides the function of a data network into layers. So each layer works with the layers above and below to transmit data. So two layers of the OSI model are so closely tied that according to the TCP or the IP model, they are in essence one layer. So those two layers are the data link layer and the physical layer. So on the sending device, it is the role of the data link layer to prepare data for transmission and control how that data accesses the physical media, and however, the physical layer controls how the data is transmitted onto the physical media by encoding the binary digits that represent data into signals. On the receiving end, the physical layer receives signals across the connecting media, and after decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. And this chapter begins with the general functions of the physical layer and the standards and protocols, or the physical layer and the standards and protocols that manage the transmission of data across local media. So it also introduces the functions of the data link layer and the protocols associated with it. So in the chapter 4, there are the physical layer protocols, the network media, and the data link layer, and the media access control. And for the chapter 5, the Ethernet, it is the Ethernet protocol, the LAN switches, the address resolution protocol. And so for the introduction of chapter 5, the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. So Ethernet is now the predominant LAN technology in the world. So Ethernet operates in the data link layer and the physical layer. So the Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. So when messages are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. And because Ethernet is comprised of standards at these lower layers, it may be understood in reference to the OSI model. So the OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. So Ethernet standards define both the layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media, bandwidths, and other layer 1 and 2 variations, the basic frame format and address scheme is the same for all varieties of Ethernet. So for this chapter, it examines the characteristic and the operation of Ethernet as it has evolved from a share media, contention-based data communications technology to today's high bandwidth full duplex technology. And for the chapter 5, it is the Ethernet protocol, the LAN switches, the address resolution protocol. And the chapter 5 is Ethernet is the most widely used LAN technology today. And on most Ethernet networks, and devices are typically connected on a point-to-point basis to a layer. So 2 full duplex switch, a layer 2 LAN switch performs switching and filtering based only on the OSI data link layer and the MAC address. A layer 2 switch built as a MAC address table that is uses to make forwarding decisions. So layer 2 switches depend on routers to pass data between independent IP subnet networks. And for the chapter 6, the network layer, it is the network layer protocols, the routing, the routers, configure a Cisco router. So for the chapter 6, network applications and services on one end device can communicate with applications and services running on another device. So this chapter focuses on the role of the network layer, and it examines how it divides networks into groups of hosts to manage the flow of data packets within a network. So it also covers how communication between networks is facilitated, and this communication between networks is called routing. So the network layer or OSI layer 3 provides services to allow end devices to exchange data and across the network. To accomplish this end-to-end transport, the network layer uses for basic processes the IP addressing for end devices encapsulation, routing, and the encapsulation. The internet is largely based on IPv4, which is still the most widely used network layers protocol. An IPv4 packet contains the IP header and the payload. So, in order for routers to be reachable, the router interface must be configured. To enable a specific interface, enter interface configuration mode using the interface type and number global configuration mode command. So, for the next chapter, the chapter 7 or the IP addressing, it is the IPv4 network addresses and the IPv6 network address and the connectivity verification. So addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. So both Internet Protocol version 4 or the IPv4 and Internet Protocol version IPv6 provide hierarchical addressing for packets that carry data. And designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So this chapter examines in detail the structure of IP addresses and their application to the construction of testing of IP networks and subnetworks. And for the chapter 8, the subnetworking IP address, the subnetting IP network, it is the subnetting an IPv4 address or network, then addressing schemes, design consideration for IPv6, and the summary. So this chapter is all about the subnetting IP network. So in detail, the creation and assignment of IP network and subnetwork addresses through the use of the subnet mask. And after it is an IP network needs to be tested to verify its connectivity and operational performance. And for the chapter 9, the transport layer, and the transport layer, these processes described on the OSI transport and layer accept data from the application layer and prepare it for addressing at the network layer. So a source computer communicates with a receiving computer to decide how to break up data into segments and how to make sure none of the segments get lost and how to verify all the segments arrive. So when thinking about the transport layer, think of shipping department preparing a single order of a multiple packages for delivery. And for the chapter 10, it is the application layer protocols and well-known application layer protocols and services. And for the chapter 11, it is the network design, the network security, the basic network performance, the network troubleshooting, and the summary. So So Syscal's configuration files such as startup config or running config should be archived, and these files can be saved to a text file or stored in a TFTP server. Some models of routers also have a USB port, and a file can be backed up to a USB drive. If needed, these files can be copied to the router and or switched from the TFTP server USB drive. And that's all, guys, for my summary video of the chapter 1 to chapter 11, and I hope you got I hope you got some informations about the or all about rather the chapter 1 chapter 11 from the Cisco Net Acad. So I hope you like this vid, and I hope you subscribe to my YouTube channel. And that's all, guys. Thank you for watching.